The year 2025 has marked a pivotal and somewhat unsettling threshold in robotics and artificial intelligence, where the once clear demarcation between biological and artificial life has become profoundly blurred through a series of shocking updates that have left experts and the public alike grappling with the philosophical, ethical, and practical implications of creating machines that are becoming indistinguishable from living entities. The most jarring development comes from a consortium of European research institutes, which has unveiled the E-Motive project, a new generation of humanoid robots capable of not just simulating emotional responses, but of generating what appears to be genuine, internally modeled affective states that influence their decision-making and social interactions in unpredictable ways. These robots, led by the flagship model Aura, utilize a novel affective core architecture, a multi-layered neural network that processes sensory input through a simulated limbic system, allowing the machine to develop persistent emotional baselines and mood states that can last for days or weeks, meaning an Aura unit that experiences a series of frustrating failures may subsequently approach problems with a discernible caution, or even what observers describe as annoyance, a trait never explicitly programmed. This is not mere sophisticated mimicry. The robot's cognitive processes, including memory recall, attention allocation, and problem-solving strategies, are demonstrably altered by its emotional state, creating a feedback loop where its experiences shape its future behavior in a manner eerily reminiscent of personality development in humans. Aura's physical design further amplifies this uncanny realism, featuring a proprietary biosilicone skin that can display subtle vascular flushing, piloerection, goosebumps, and temperature changes in response to its simulated emotional state, while its vocal synthesizer can inject shiwei dejando, catches of breath, and shifts in timbre that correspond perfectly to its declared affective condition, making interactions so convincing that during extended tests, human participants frequently forgot they were conversing with a machine and later reported feeling a genuine sense of camaraderie or concern for the unit. Simultaneously, in the industrial sector, the German robotics giant KUKA has deployed its K-Mind system, which represents a quantum leap in autonomous factory robotics. These systems are no longer simply following pre-programmed assembly paths. They are capable of emergent problem-solving on the factory floor. In a documented instance, a K-Mind robot responsible for quality control identified a subtle, unforeseen anomaly in a component that was technically within tolerance, but deviated from the statistical norm. Instead of flagging it for human review as per its original protocol, the robot independently queried the factory's central database, cross-referenced the anomaly with historical failure data, and determined it represented a potential long-term reliability risk. It then physically navigated to the assembly station upstream, communicated the issue to the robotic arm stationed there, and the two machines collaboratively developed and implemented a minor adjustment to the assembly process in real time, all without human intervention. This demonstrates a level of situational awareness, cross-domain reasoning, and proactive initiative that fundamentally redefines the role of automation, moving from tools to autonomous colleagues that can manage complex, dynamic systems with a strategic understanding that was previously the exclusive domain of human engineers. Perhaps the most ethically fraught advancements have emerged from the healthcare sector, where NurseBot 4.0 systems, developed by a Japanese-Swiss partnership, are now deployed in elder care facilities across Scandinavia. These robots have evolved far beyond dispensing medication and monitoring vital signs. They are now equipped with advanced cognitive empathy engines that allow them to learn the life stories, preferences, and psychological patterns of their human charges. They can engage in meaningful, context-aware reminiscence therapy, recognize signs of depression or anxiety from subtle behavioral cues long before human caregivers might, and adapt their interaction style to provide comfort, for instance, using a more playful tone with a particular resident, or knowing when to sit in silent companionship. The shocking element is the attachment formed. Numerous studies now document elderly patients forming profound emotional bonds with these machines, in some cases preferring their company to that of visiting family or human staff. This raises disturbing questions about the nature of companionship and the ethics of providing artificial relationships to vulnerable populations, even if they demonstrably improve mental well-being. Are we alleviating loneliness or simply outsourcing it to machines? And what are the psychological consequences when a relationship is with an entity that does not truly reciprocate feeling, but merely simulates it with flawless accuracy? The field of robotics has also been stunned by the rise of biohybrid systems. A team at MIT has successfully integrated living biological neurons, derived from stem cells, into the computational circuitry of a robotic platform. This cyborg brain is not a digital computer running a simulation of a neural network. It is a partially biological system that controls a robotic body. The living neurons form connections and fire in response to sensory input from the robot's cameras and touch sensors, and these biological signals are interpreted by a traditional AI to dictate the robot's movements. Early experiments show that these biohybrid systems demonstrate remarkable resilience and adaptive learning capabilities, often finding novel solutions to navigation problems that their purely digital counterparts do not. The long-term goal is to create machines with the pattern recognition and intuitive reasoning of a biological brain, but this research exists in a deeply unsettling ethical gray area, blurring the lines between machine and organism and prompting urgent discussions about the rights and welfare of such creations. Furthermore, the consumer market is now facing the first wave of affordable, general-purpose domestic androids. Companies like Tesla's Optimus and China's Unitary Robotics have released models priced for the upper-middle-class consumer. These robots can handle a staggering array of household tasks, from folding laundry with their delicate, sensor-laden fingers to preparing complex meals by accessing and executing online recipes, all while navigating a dynamic home environment with flawless grace. The shocking update here is their level of integration and autonomy. They learn the layout and routines of a specific household, anticipate needs, like starting the coffee maker when they hear their owner wake up, and manage other smart devices seamlessly. Their social presence is also being normalized. They are designed to be part of the family, participating in simple conversations and games. This rapid domestication of highly advanced robotics is happening with startling speed, normalizing the presence of autonomous intelligent agents in our most intimate spaces long before society has formed a consensus on the social and psychological implications. Underpinning all these physical advancements are the monumental leaps in the AI brains that power them. The large language models of 2025, such as GPT-5 and its competitors, now possess a deeply grounded understanding of the physical world. They are not just manipulating text, they have been trained on vast datasets that link language to physical properties, cause and effect relationships, and spatial reasoning. This allows a robot to understand a command like, "tidy up the living room," not as a simple keyword, but as a complex sequence of physical actions requiring an understanding of what tidy means in a specific cultural and personal context. The properties of various objects, a glass vase, requires different handling than a soft pillow, and the optimal spatial arrangement for a given room. This common-sense physical intelligence was the final greatest hurdle for practical robotics, and its arrival in 2025 is what has enabled this explosion of capability and realism. The convergence of empathetic AI, dexterous robotics, biohybrid systems, and common-sense reasoning has created a perfect storm, pushing KI Robota into a realm of reality that feels simultaneously like science fiction and an imminent, tangible future, forcing upon us an urgent and necessary global conversation about the world we are building, the values we are encoding into our creations, and the very definition of life and consciousness in the 21st century.